This video is about identifying special segments and lines of a circle. So today we're going to talk a lot about circle vocabulary. So to start with a circle is just this dark black solid line. When we're looking at a circle, we have an interior then and an exterior of the circle. So the interior is everything that's going to be inside that line. This would be our interior. And the exterior of the circle is going to be everything outside the black line. So when we're talking about circle, the circle is just that black line. So a couple of vocab words. The first is a chord. So a chord is a segment whose endpoints lie on the circle. So if I go from here to here, this would be a chord. So AB would be a chord. It's got a start and an endpoint. We could also call it BA. Our next is a radius. So a radius goes from the center of the circle to a point on the circle. So our radius would be CD. We could also call it DC. A diameter then is two radius that are put together that go from end to end of the circle, and it goes through the center. So a diameter is a special type of chord. So in this case, EF would be our diameter. A secant and a tangent are lines then. So a secant is a line that intersects a circle in two places. So it's going to go through our circle twice. So GH would be our tangent, and with GH it's going to have arrows, unlike the chord, radius, and diameter, which just have a line for a segment. The other type of line then is a tangent. So a tangent is a line that just intersects the circle once. So it goes up to the circle and then it keeps going. So we'll call this JK. It's also going to have arrows. The point of tangency then is that special point where the tangent line touches the circle. So in this case, K would be the point of tangency. So let's use the picture to identify the following. So given circle S, we want to name the following. We want to name one diameter. So a diameter goes from one side of the circle to the other, and it passes through the center. So our diameter would be BA with a segment bar above it. Three chords. So a chord has two endpoints on the circle. So EB is a chord. BA is a special type of chord because it's your diameter, but it's still also a chord. And RA. Now, be careful with RA. Even though it has arrows, we're just looking from A to R. So it would just be RA with the segment bar above it. A tangent line is when it's touching the circle once and it keeps going. It has arrows. So our tangent line would be ZE with arrows on our symbol. Radii. So if we have the diameter of BA, it's made by two radii. So our radius would be SB and SA. And our last one, a secant, goes through the line. So we already said that RA was a chord, but RA with an arrow is going to be the secant line with arrows on the symbol. And number two, let's match the following. So RT has arrows on it. It only touches the circle once. So that is going to be our tangent line J. H is the point that's at the center of the circle, so it's going to be our center. R is the point where the tangent line touches the circle, so it's the point of tangency. EA, this is just segment EA. So we're starting at A and ending at E, so that is going to be a chord. That is different than EA, which has the arrows, because that means it's going on forever, and that would be our secant. So make sure you know the difference between the two EA parts. Let's go back to AH is going from the center to the circle, so that's going to be our radius, which means that RE is going to be our diameter because it's going across the circle and through the center of it. So a couple other vocab words. Common tangent is a line that is tangent to two or more circles. So a common exterior tangent means it goes outside the circles, and a common interior means it goes between the circles. A couple other vocab things. We have two circles They're going to be congruent if their radius is the same length. So if their radius is congruent, then the circles are congruent. Concentric circles are circles that are coplanar with the same center. So they're going to be two circles that kind of look like a bullseye. And then we have tangent circles. So tangent circles can intersect each other in one spot. We can have tangent circles where one circle is inside the other, and we can have circles where their tangent one is outside of the other. An important thing to remember then about a radius is that all radii in your circle are going to be congruent. So anytime you are given a circle, all radii, all lines drawn from the center to the edge of the circle are going to be congruent. So in number 3, if I want to solve for x, I know my radii are congruent, so x is 31. In number 4, if my radii are congruent, we have 7x minus 2 equals 40. We can add 2 to both sides, so 7x equals 42. When we divide, we get x is 6. In number 5, when we set our radii congruent, we have x squared minus 15 is equal to 2x. We can move the 2x to the other side, so x squared minus 2x minus 15 equals 0. So when we factor x minus 5 and x plus 3 equals 0, so if we switch our signs, x is 5 and x is negative 3. Our last part, 2 circles are concentric. The radius of the smaller circle is 9. The distance between the small circle and the large circle is 4. What is the radius of the larger circle? So in concentric circles, we have one circle inside the other with the same center. So we have a bigger circle, and we have a smaller circle. The radius from the smaller circle is 9. There is a distance of 4 between the two circles. So if we were to combine that and we do a radius of 9 and a distance of 4, that would make the radius of our larger circle. So we can add 9 plus 4, so the radius would be 13 inches.